Hello everyone, this is Dr. Roberts for Intro to Electrical Computer Engineering. And today I would like to actually work the practice problems presented in week 10 of the class. And you can find these in my section this semester is week 10 Tuesday lecture, so that would have been for fall of 21, the lecture given on October 26th, right? And there are 8 problems, and we worked them, but of course, just so we can work them again. And you also look, these static solutions for this have also been posted on Blackboard, so you can find those PDFs as well already worked out. But I know sometimes seeing someone work it is more convenient than just seeing a piece of paper, right? So hopefully we can walk these together and this may be helpful for you. So the first practice problem has the following circuit, right? Draw this thing up. And one thing you'll realize as electrical engineers, we spend a lot of time drawing. Doesn't mean, in my case, that I become an artist, but eventually you'll get, your resistor drawing skills down and everything else, right? So we have this circuit, and there's 2 parts to this question. Part A asks you to find the equivalent resistance, REQ, in shorthand notation, okay? And part B asks us to determine the voltage V sub A in shorthand notation, okay? Right? So, what we can see if we do this is we have this circuit, and if we look, and here's V sub A, these ones, there's a node, but these 2 are in parallel, so we can combine them, right? And if we do that, we get this circuit, Vn, this is R1, and since R2 is parallel R3, the new equivalent there is R2 parallel R3, and this right here is still V sub A, right? Because the wire hasn't changed. Now we combine it again, and if we did that again, right, these 2 are in series, right? There's only one wire connecting them, right? And so if we do that, we can combine them. So we do that. Now, Vn was between the 2 resistors, or Va, excuse me, right? Va was between them, so it's now gone. It's buried somewhere in here, but the equivalent resistance then is this. What? These are in series, so it'll be R1 plus R2 parallel R3, right? So for part A, R equivalent is going to be R1 plus R2 parallel R3. Now, part B asks, okay, well, find VA in shorthand notation. Now, if we do that, okay, here VA has been buried. VA still exists here, and this is kind of the simplest form where VA exists, right? Because here it's complicated. If I look here, I have 2 resistors in parallel. So, hey, that means I can use then a voltage divider, right? So our voltage divider is, so using a voltage divider, right? We know that V sub I is going to equal to Vn times R sub I over R equivalent, right? We learned before, voltage divider, the voltage you want to measure is equal to the input voltage times the resistance of whatever the voltage you're trying to measure across over the equivalent resistance. So we already have the equivalent resistance we found for the circuit, and our V sub I we want to measure is VA, and VA is measured to ground. So VA is measuring across this resistor, where this resistor is R2 parallel R3. So if we do that, you say, oh, okay, it's equal to Vn. So our R sub I is R2 parallel R3. And our R equivalent is going to be this, R1 plus R3. Just like that. So that is practice problem 1. And again, here you see, right, we found the equivalent resistance, and use shorthand notation. It's very convenient, and we can later plug it in. And then we also found a relationship for V sub A. Thank you very much, and I'll see you in the next video.